let's read the question together. This question has an introduction or a rubric, so let's read that sentence. Aluminium can be extracted from purified bauxite ore. So this has given us some information. We are collecting aluminium and we're collecting it from bauxite ore. Now, what is an ore? It is a chemical compound whereby the percentage of metal is economic to extract from that compound. Now, many metals are very reactive and they're found in minerals in nature, and if that percentage of metal in that mineral is high enough to make it worth me mine it or quarry it and then extract the metal, then we would call it an ore. Looking at part A, give the formula of the electrolyte used in aluminium extraction. So what's the command word? The command word is give. What other information am I given in the question? They want a formula, so a name won't do it. And they want the formula of the electrolyte used in aluminium extraction. So the name of the electrolyte is aluminium oxide, also known as alumina. That, of course, is not the formula. You need to be able to write the formula down. So aluminium oxide contains, of course, aluminium and oxygen. And aluminium makes 3+ ions and oxygen makes O2- ions. So you're going to need 2 aluminium ions for every 3 oxide ions, giving you the formula Al2O3. Part B. Explain why cryolite is added to the electrolyte. So what's the command word? The command word is explain. What other information have they given us in the question? That we add cryolite to the electrolyte. Now, why do we do that? Now, we add cryolite to create a mixture to actually dissolve the aluminium oxide. Now, a mixture usually has a lower melting point. So, the first thing I would do is make a note of that. So, it's to lower the melting point. Well, so what if I've lowered the melting point? What does that mean to me? Well, it means I need less energy to melt it. And remember, electrolytes have to have ions that are free to move, otherwise electrolysis can't happen. And that can only happen if the ionic compound is dissolved in water, and aluminium oxide doesn't dissolve in water, or if it is molten, a liquid. So if I require less energy, from an industrial point of view, that means that the costs are reduced. So let's reflect on where the marks would be. We can see this is a 3-mark question. We have 1 mark because we're stating that by adding the cryolite we lower the melting point. The second mark, we're then suggesting why that's important, i.e. less energy is needed to melt the electrolyte. And the final mark is for relating that to an industrial process, and that will reduce the cost of extraction. Let's look at part C. Write a half equation to show the formation of aluminium metal during electrolysis. So, what is the command word here? The command word is write. What information has the examiner given me in the question? They want a half equation, and they want that for the formation of aluminium metal during electrolysis. So, what is a half equation? It tells you half the story, as the name suggests. It can only show you reduction or oxidation, not both at the same time. And it has to be balanced in terms of atoms present and also the charge. So let's have a little think about this. I'm making aluminium metal. So I know that that is the product, so I can add that there. I know that that is going to be a chemical reaction, a chemical change. So therefore, I can add an arrow because it's a goes to arrow. So now I know the product and we're going to, but what on earth am I starting with? So we're beginning with aluminium ions. And of course, they are in group 3. So in order to be an ion, they will lose their outer shell electron and they will have a charge of 3 plus because they have 3 electrons in their outer shell. Now, it's balanced in terms of atoms. One aluminium ion becomes one aluminium atom, but it is not balanced in terms of charge. On this side, we've got a charge of 3 plus, and on this side, we have no charge at all. It is neutral. So how do I balance the charge? I can add electrons. And of course, in electrolysis, that is exactly what happens. Now, if I add just one electron, that's not very good because now the charge on this side is +2 and the charge on this side is still neutral. So I must add 3 electrons, 3 negative charges to offset the 3 plus from the charge from the aluminium ion. And this is now totally balanced and a half equation. So where am I getting the marks? I'm getting 1 mark for the correct reactants. I'm getting 1 mark for the correct product. And I'm getting 1 mark for the correct balancing.